So you may have gone to the eye doctor before, and they might have put these drops in your eyes to dilate your pupils. And they're doing that so they can, look into your eye, make sure that it's healthy, make sure everything in there looks good. We're going to be talking about dilations today. So by the end of this lesson, hopefully you'll be able to identify and create dilations of plane figures. So copy down your target. You are going to need a ruler for this class, so if you need to pause the video and go grab one, do that now. So what does it mean to be dilated? You think about your pupils. When they're dilated, they get really big, right? Now, I've never seen one this big, but your pupils enlarge and then reduce in size, and they adjust, to light, to when you're maybe telling a lie, to things that surprise you. That causes your pupils to dilate. Well, dilation is a transformation that changes the size, but not the shape of a figure. So translations or slides, reflections or flips, and rotations, which are like turns, are transformations that do not change the size or shape, but a dilation does change the size. It can reduce or enlarge the figure, and the way you're going to know if it reduces or enlarges is by the scale factor. A scale factor describes how much a figure is reduced or enlarged. If it's between 0 and 1, the figure will be reduced down, but if it's greater than 1, then the figure will be enlarged. It'll get bigger, okay? So fill in those blanks, make sure you have your target. Let's practice identifying dilations first. I'm going to give you a little, an easy way, a hint on how to do this. Draw a line that connects each pair of corresponding vertices for each figure. If the lines intersect at one point, then the transformation is a dilation, and this point is called the center of dilation. So let's try this. Let's look down at A. Tell whether each transformation is a dilation. If so, label the center as point O. Let's first draw lines that connect each pair of corresponding vertices. So this is the top left corner of this rectangle. I'm going to connect that to the top left corner of this rectangle, and I'm going to continue this line on. So make sure that it ends up that these two are connected, and then I'm just continuing it on. Doesn't matter how far, but extend it out there a little ways. Then use your straight edge or your ruler, connect the top right corner of the rectangle to the top right corner of this bottom rectangle, and again, just continue that line on. We're hoping that they're going to intersect at one point, so you want to extend it out until you're going to reach that intersection. Let's connect the bottom right vertex with the bottom right vertex down here, and the bottom left vertex with the bottom left vertex. Is this a dilation? Well, do all the corresponding vertices, are they connected but lines that intersect at one point? Yes. So this is a dilation. You may have done something like this in art class with a perspective drawing maybe. Your center of dilation here is O. When you draw perspective drawings, a lot of times your point that you're dilating by might be off on the horizon. But this allows us to create a three-dimensional figure. So that is a dilation. Great. With B, let's try this again. Again, connect corresponding vertices. So you want to kind of predict which way it's going to connect. I could draw a line like this and move it around until I'm touching the vertices going out on both sides. But you have to figure, where would my center of dilation be? Is it going to be on the left of this drawing or the right? As you go on and connect the other vertices, are they going to intersect over here on the left, or are they going to intersect over here on the right? Well, they're going to intersect on the side that's the smaller one, right? Because this line's going to tip up this way. If I extend it out over here, that's getting way too far, and we can even show that. But those aren't going to intersect over on the right. They're actually getting farther apart. So, okay, these two vertices are lined up, and then let's connect R prime to R, and when we do that, we actually already connected P prime to P. Those are corresponding vertices. So when we look at this, is this a dilation? No, there's no center here. There's no one point that they're intersecting. This is not a dilation. So again, a dilation the idea of using these lines is very similar to what you do maybe in a 1-point, 2-point perspective drawings. So you can kind of see it in art class as well. All right, for example 2, we're going to dilate a figure by a scale factor of 1.5 with P as the center of dilation. So there's a little typo there, change that to center of dilation. The first thing I want you to do is copy down these steps, okay? So write down these steps in the margin. You can pause the video to do that, and then we'll dilate this together. So I already measured my side lengths, but that's going to be the first step. The first step is going to be to measure each side, and I already did mine, and I measured mine in millimeters. You can measure really in whatever you want, okay? So when I lined this up, I saw that the P to Q, from 0 up, was 65 millimeters, from P to R was 72 millimeters, and from Q to R was 32 millimeters. So now, the step 2, I'm going to take those lengths, and I'm going to multiply them by the scale factor. My scale factor is 1.5, so my figure is going to be enlarged. Remember, scale factor over 1 makes it bigger. So we have 65. We're going to multiply that by 1.5. We have 72. We're going to multiply that by 1.5. And we have 32. I'm going to multiply that by 1.5. Now, I'm doing my measurements. Your measurements will be different. I measured mine on the board. You're going to be measuring yours on your paper. It's a little bit smaller, so make sure you use your measurements here. Find your measurements. You can pause if you need to, and then multiply them by 1.5. So in my measurements, I got 97.5 millimeters, 108 millimeters, and 32 times 1.5 is 48 millimeters. Again, your numbers will be different. Now you're going to draw the new lengths from the center of dilation. You always draw the lengths from the center of dilation. In this example, I'm dilating by point P, which is part of my figure. So I'm going to remeasure the side. I'll do this in blue this time, but I'm going to measure it from P all the way up until I get to the new length. 65 times 1.5 was 97.5. So I'm measuring from P all the way up until I get to 97.5. So I'm getting to about there. There's going to be my new length. And then I can turn the ruler. Oops. I'm going to measure my other side. Try to line it up the best as you can. Now the 72 length became 108. So I'm going to go down to 108 and draw that in. So you'll have to use your ruler. I'm using mine. The last side then. Oh, the last side should be 48 millimeters, and I just actually have to connect it out with here. So let's just check the 48 that is about right. From 0 up to there, yeah, that's right about 48, so I did a good job. All right, so there's my new figure. When you dilate a figure, you need to name your new vertices. See, the PQR is my pre-image, and now I'm going to get my new image. So PQR is going to be P prime, Q prime, and R prime. It's like a little apostrophe or a little 1 up top, and that's saying that's my new figure. You can label your new figure with the lengths too, or you have them right down here, and that'll be just fine. So you think about it, maybe medical professions would use dilations too when looking at x-rays. They may zoom in or enlarge the x-ray to get a better look at a break, especially in small babies or animals. Veterinarians might use it too. And the last example, we're going to dilate a figure by a scale factor of 1/3 on a coordinate plane. So we can dilate just a regular image. Now let's dilate an image that's on a coordinate plane. Start by identifying your vertices. So what is your A, B, and C? Write those ordered pairs down. Well, A was over 1, 2, 3, and up to 9. So it was over 3, up 9. Remember, the X comes before the Y. B was over to 9 and up to 6. And the C has an X value of 6 and a Y value of 3. So far, I have these ordered pairs. When you dilate on the coordinate plane, you're still multiplying by that scale factor. We're going to multiply these points by 1/3. And guess what? You multiply the X and the Y by 1/3. You have to multiply everything you see. That's going to give me my new A, my new B, and my new C. So my image, what's coming from A, B, and C are my images here. These are your new ones. So put those primes on there and let's multiply. 3 times 1/3 is 1. 9 times 1/3 is 3. All you do is multiply the x, get your new x, multiply the y, get the new y. Try B and C, and then we'll see if you got them right. So B prime would have a value of 3, 2, and C prime would have a value of 2, 1. Now all we need to do is graph our new image. We have the vertices stated, so we're going to go over 1, up 3, and that's going to be my A prime. So put those primes on there. For B, we're going to go over 3 and up 2. And for C, we're going over 2 and up 1. Let's connect our vertices. Use your straight edge. And there's our new image. So if we connect these vertices, they should go through, if we connect the corresponding vertices, we should see the point that they go through. Let's do that just to check, just to make sure that this is a dilation, just like we did in example 1. So I'm going to connect my A to my A prime, my B to my B prime, and my C to my C prime. Do they go through the same point? Yeah. Looks like we're pretty close. We may be a little tiny bit off, but it looks like they go right here through the origin. The origin is your center of dilation. We'll always use the origin as our center of dilation on a grid. You can do it a different way if your origin is not the point of dilation, but we're not doing that in this lesson today. That's it for the lesson. There's 2 challenge questions if you'd like to try them, and I'll post the answers on Blended Schools.